Okay, good morning, class. Last week we discussed where we talk about software engineering, and we say that software engineering is a process of developing software using engineering method. Process. That means there are things that will need to be done. There are things that need to be done in order. We also say that software development follows engineering principles. So those principles have to do with design. Those principles have to do with using the right tools. Those principles need to do with measurement. Just take, for example, someone that is a carpenter, for instance, and you take your chair to where you want them to build a chair for you, and you are there, two carpenters. The first one just say, okay, you want a chair. He didn't ask you the size of the chair, the color you want for your chair. Just say you want to build a chair. You say yes, it's okay, it's 10,000. Give him 10,000. He just went, he didn't ask you anything, he just went and carry timber, get the what they call plank and start cutting it. He didn't even measure it. He start cutting it, he cut this one, he cut this one, he start doing it, start building it. You find out that at the end, when the person is done, he's sure that the chair will not suit what you want. Because in the first place, he didn't ask you the type of chair you want to build. He didn't even ask you the size. Neither did he, at least. So you now go to the next person, and the person asks you, okay, sir, what size of chair do you want to build? And after that, he said, okay, do you want me to use a local wood or foreign wood? He said, use foreign wood. Say, foreign is expensive, it's 1.5. Say, use foreign. He notes it down, foreign wood. And that's okay. Is that all? You say, yes. He said, sir, what of your in color? What's your best color, sir? He said, my best color is blue. He said, okay, he notes it down. When you are coming to take that car, that chair, you see a blue chair of that size that you want. This man and this other man, which one would you prefer? If you have work next time, even if the second man charge you higher, remember the other one didn't ask you what you want. He just used a local wood and build it. Maybe charge you 5,000. And this one asks you what you want and build it with 10,000. Next time you want to build a chair, or you see someone that want to build a chair, who will you recommend? Because he didn't just build a chair, he also asked you your best color, and he used the color that you appreciate to build it for you. That is what it is about software engineering. And that's the difference between software engineer and developers or programmers. They may not go to details to find out those things we call non-functional requirements. Those ones that the owner didn't say. You can hardly go to build a chair and you say, build a chair for me and make it blue. No, you don't. You can define all the things you want, but you may not go to the point of saying color. But because this guy wants to know what he will do to appeal to you when you see the chair, he went ahead to ask you the best color you want, and he implemented it. So that's what software engineering. Why software engineering is a higher level, in terms of when you want to develop a software compared to developers or programmers. Information gathering. That's the number one process. We don't just take the person's word for it. Do a software for me that will do this. You now start coding. You need to ask further questions. You need to gather more information from it. After that, you use those informations to do a design. After you have done with the design, you develop it. After developing it, you test it to be sure whether this thing is what they want me to do. After testing it, you deploy it. You give the person the software. When you give the person the software, that's the end of the work, right? I'm expecting feedback.
No.
What's the next?
Maintenance.
Maintenance. So you don't just do the software and go. That's one advantage. If you do 3 big software in a year as a software engineer, you are covered because they will still be paying you for the maintenance when you are done developing the software. They will still be paying you for maintenance. If they dare call another person for that maintenance, you thank your God because next time you're going to charge them millions because that person is likely going to make mistake. In fact, as a software engineer that you are becoming, any software that another person build, don't accept to go and maintain it. Because if you make mistake, the owner of that software can sue you to court and lock you up. Because you mess up with their software, it's their property. Except, of course, they will give you the document for you to go through. So when we say that software engineering is a process um, and follows engineering procedure, that is what we mean. Software engineering is not just to sit down on a laptop and hit the keyboard in the name of writing code. You have to observe the engineering procedures. You have to observe all the processes that are involved. The first point, the first point is information gathering. The last point is maintenance. Maintenance and information gathering connects again to form a cycle. And that is what is called software development lifecycle. And that's what we want to discuss today. And because it's a continuation of last week's class, and software development lifecycle cannot exist without going back to talk about the software engineering process. Because what we are cycling is the process of software engineering. So we are going to, you may think that we are going back to what we learned last week. We are correct 50%, but the other 50% is that we are seeing how the loop continues to form a cycle in what we call software development lifecycle. There is a PowerPoint for this work, but it's not available now, so we are using this one as well. We're not going to read it verbatim because if it's the PowerPoint, you know it's going to be abused. So I'm going to be moving it as if it's PowerPoint. So note that. Introduction. Software development lifecycle is a critical framework for developing reliable and scalable software. Understanding its phases and models is essential for software engineers and developers to ensure that projects are completed on time, within budget, and according to the required standards. I mentioned something here about phase. Say understanding its phases and models. So software development life cycle is a cycle of phases. Each software development has a phase. The phase is that process that we talked about. Phase 1, information gathering. Phase 2, analysis. Phase 3, design. Phase 4, implementation. Phase 5. Those phases go round the clock and form a cycle. The aim of that is to make sure that we develop a software that is complete and we did it on time. And again, it is within budget. If you say that the software, they're going to use 150,000 to develop this software. If you don't follow engineering process, the software can take much more money. But if you follow a process of design, you'll be able to know how much the software will cost. That's why before you give code for software, you must have had at least the second phase of the software development lifecycle, which is you must have gathered the requirements, you must have done the basic analysis to know what it will take. So people don't just call you and say, Engineer Musa, so you're a software engineer now. You say, yes, okay. How much will you take to do a software for me to manage my small business? You now say 50,000 or you say 500,000. Another engineer around will know that you're not an engineer yet. Because you can't just give code without asking the person, what will the software do? And that is the information gathering aspect of it. You now say, okay, I just want to use it to keep record of my account, my cash flow. You can ask another question based on that. Is it only cash payment or including the ones transferred through the bank? You now keep gathering until you understand fully what the software is. You write it down and you show him. "Sir, is this what you want me to do?" You look at it and say, "Oh, yes, that is it." That is when you can now give quotation as in terms of pricing. Because you can just say, "I want you to do small software for me to manage my small business." And in your mind, you are thinking that since this thing is a shop, he is talking about inventory management, he is talking about his staff management, he's talking about his cash flow, and he's talking about reminders, because all these things can be part of a software that you use to manage small business. And because you think he's talking about all these things, you now charge him 1 million. You say, that's too much. I can't use this kind of money to do software. How much is my business worth? He now go and meet Engineer Chedi. I say, "Engineer Chidi, I want a software that will help me manage my business." As a seasoned engineer, I will now ask him, "What and what do you want the software to do for you?" He now say, "It's only finance." And I ask, "Is it both transfer and?" He said, "No, only cash that come to me because I'm not usually there. It's my staff. I want to check if they are stealing my money. The transfers goes directly to my account, so I don't need record." I say, "Okay, only cash." He say, "Yes." 200,000. He now say, "You see, Musa is charging me 1 million." He didn't know that you charge him like that because what you are thinking is different from what he wants. That's the reason why we ask those questions. So that what you are doing will be within a reasonable budget for the work. Let's turn the table around. Imagine if the person want to manage the whole business. Like he's maybe Auntie Bola, for example, now have a business and he called you using the experience you had with the first man, and yet you didn't learn a lesson. You didn't ask questions. Auntie Bola said, "I have a boutique and I have two sales girls now. So I want something, software that I can use to manage my business." You now come and say, Auntie Bola is our family's, okay, 180. You say, 180,000. You say, okay, it's fair. Oh, yeah, now, start. He give you 100,000 to start. You now went and do finance management only. You now put it, you now say, I'm not seeing what is in my shop now. If they sell two clothes, how will I know? I want the software to show me now. I can manage the inventory. So if anything go out of my shop, I will see it on the software. And I want it to be mobile. This thing you did, I don't have laptop. I want it to be on my phone. You now go back and do a mobile app. A mobile app that will do inventory management, do finance. You now bring it. You now look at it and say, I'm not even seeing when my staff come to work and whether they come late or they didn't come. I want to be able to see the day they come and the time they come so that I can know the person that is coming late and the person that is not coming late. You now go back and borrow money. Because you must complete it, otherwise she will arrest you. Because there's an agreement. And this thing you are doing now is running into 2 million. Before you can do a software that will do all this in mobile form, is over 2 million. But you charge 180 because you did not follow engineering process. Do you understand now? But if you have followed engineering process, when she say a software, you say, "Okay, Auntie Bola, what and what do you want the software to do?" She will now say, "I want to track attendance. I want to track timing. That is punctuality. I want to track inventory of my shop. I want to track finance." And okay, so this software, do you want it to be a website or you want it on a desktop in your office? Say, "No, I want it to be a mobile app. I want as I'm walking along the road and seeing what is happening in my shop." Do you understand what is questioning? So in her mind, I just want the software to manage my business. That is the requirement. But for those non-functional requirements, you have to dig it out of her so that with it, you can form your requirements document. And with it, you can know what to charge. So let's take note of those things, that software engineering is not programming. So that you don't go collect a job as a software engineer. Because as a software engineer now, you become a consultant. So people that want to build software, they will consult you. Because you are now like an engineer of this one. You build custom software for people. And you must follow those engineering processes if you want to be successful in it. What is software development lifecycle? Software development lifecycle is a systematic process used by software engineers and developers to design, develop, and maintain software systems. It defines a structured approach for software development, ensuring quality, efficiency, and consistency. The software development lifecycle process includes several phases, each with its distinct objective and deliverables. These phases guide the development team from the initial planning phase to the final release and maintenance of the software. The main objective is to produce high quality software that meets or exceeds customer expectations within a specified timeline and budget. Budget, very important. If you charge lower, you go and borrow money and complete it. And if you charge too much, you will lose the job. So budget is important, and you can only know what budget is when you follow this process of information gathering and analysis so that you know what each costs. Some persons that want software developed for them, they will not tell you whether they want it to be on their phone or they want it to be on the site, like a web-based or off-web. They will just tell you what they want. You be the one to find out. Sometimes too, software don't need to be mobile app. There's technologies you will use to develop a website that will make a software run normally on a phone because mobile apps are costlier than web-based apps. So what you do is to find out whether this person really need a mobile app or he's talking about a software that he will be able to use with the phone, irrespective of where it is. If that is the case, you do it on web, which is cheaper. Because everybody, something that is within budget is important. You don't need to do your work too expensively. Even if you are doing it for Dangote, he will appreciate it when he spend less. Are you following? So you need to make those requirement analysis to be sure that what you're doing is within budget. So let's look at those phases. We said that software development life cycle is a phasal some stuff. It has phases. So in those phases, we have even caught up across those phases. Even last week we talked about them. I've already given you a summary that what software development life cycle does is to connect those phases that we learned last week and use them to form a cycle to continue. At the end of the maintenance, it continues with requirement again. But let's look at it more elaborately. The first phase is planning and requirement gathering. I want to explain what this sentence means. We're not talking about planning the software. We're talking about planning the information gathering. You don't just go, you want to gather information, you just leave your house and you go, you want to gather information. You may not remember all the things that are necessary for you to ask. You first of all plan it. What am I going to ask Auntie Bola? You write it down. I will ask her. You can even ask her how much is she budgeting for this work? Because you also need to consider that if her budget, like I was saying now, maybe she says she wants a software that will run on her phone, and you just think by yourself that she's talking about mobile app, and you know that mobile apps are more expensive than web-based. And if her budget cannot allow her to have a mobile app, you can advise her, Auntie, let's do this thing on web, but we use a technology that will make it easy for you to browse with your phone. Are you following? Let's use a technology that will make it easy for you to browse this software with your phone. Because you are looking at her own budget. Because if you go by, okay, since you say his mobile app is 2 million, and Auntie Bola look at her budget, she don't have 2 million. You have lost that job. So before you go to gather these requirements, you have to plan it. You have to make a plan of the information that you are going to gather. Take a note of them. Then when you now get there, that document will guide you to gather the quality information that you want to gather. So the objective of planning the requirements of the software is to define the problem and gather requirements. Requirements are what and what will this software do? How do you want to use it? Who and who will use it? What's the level of education of the people that will use it? This, what is the budget that you're expecting? You consider all these things and then you gather the information. The activities you will do here is identify the purpose of the software, the goal and the functionality. Then you meet with the stakeholders. So, like I said, the stakeholders here are not just the Antibola. All the people that will use the software with her, you also have to consider them. They are the stakeholders of the software, not just the owner. So you go to her, you go to the, after you have discussed with her, because she's the one that owns it, is her idea, is her payment. You go to that her staff, Miss BC. Do you know that Antibola is the software for this shop? She said, yes, she told us. She said, okay. Have you used computer before? She said, no. That information will help you know how you will do the user interface. You're not going to do it so complex, but if you do it complex, she'll not be able to use it. And if she is using it wrongly, Antibola will think that the software you develop is not good because the users are not able to use it. So when you are gathering information, all the stakeholders will be involved. If there is the owner of the business, maybe Antibola is just the manager of those staff, but there is someone that is paying for the software, you still have to go and meet the owner of that company because his own is to receive reports. He's not going to key in data. You go to him and ask him, sir, what type of reports are you expecting from this software? Sir, you know Antibola is using software. He say yes. It's okay. What type of reports do you want to be seeing from this report? And how often do you want to see them? He said, well, we want them to be keeping daily record, but I'm a busy person. I want to be seeing them monthly. I want to be seeing them weekly. Or he can say, I just want to see, anytime I feel like seeing what is happening, I just want to key in and see what is happening. So this is will help you. You now know whether this report you are going to module it weekly, monthly, or in real time. So your information gathering will not end at Antibola alone who contracted you. All the stakeholders, all the people that have access to that software legally, you have to meet them and know what their expectation is. Otherwise, the software may not be usable. Another reason we gather this information is to create software requirement document. This document is what will help you to develop the software. Remember, you don't have to be going to these people all the time. That once is enough. Just go to them, gather all the information you need, document it, and now use that document to do your design. You also have to carry out feasibility studies. Let's say, for instance, you are not used to mobile app and they insisted that it's mobile app they use. You have to do some feasibility to know how possible it is. Like I remember when I was doing mobile app, it's Android that we are using. That time it's only big men that use iPhone. But now students are using, everybody using iPhone. So it's not like that time that before you hardly see a software you are building and the person says it's iPhone based. No, it's Android everywhere. Android. That time, like 2018, 2017. But now everybody is using iPhone. So you have to find out which technology works best. If you want to do a software that will work both in iPhone and Android, it's a feasibility study kind of. So this time around, you're not asking Antibola and her team alone. You still go out of the way to do your feasibility studies before you can quote the price. And so those are what information gathering will help do. And that is the first phase in software development life cycle. It's a process. The first phase of that process is information gathering. The second phase is system design. So at this point, you've known everything that is about that software. You now start the design. So in the design, you start structuring how the software will be. You design the database. You design the user interface, you design the controller. That's the algorithm that will, if you click here, you get this. If you do this, you get this. If you right click, if it's mobile app, if you long press, all those designs, you start making them on paper. It's architectural. You know, when we say architectural, like the architects that build house, you have to draw, you have to sketch. These are the processes that you have to follow to get the design done. Then again, in the design process, you choose the technology that will be used for this work. Because there's a lot of technologies. When I say technologies, I mean programming languages. There's a lot of programming languages. So you have to pick the one that is most suitable for this work. When you do that, you produce another document. This document is called System Design Document. The first one is System Requirement Document. This one is System Design Document. It is this document now that you will now give to the programmer or the developer. I don't know the terminology you want to call the person, who will now sit down and type on the keyboard these designs, these requirements. You have gathered it, you have designed it, you now hand it over. Using architectural engineering, for instance, at this point, the architect is done. You now hand it over to a builder, a mason, who will now look at those house plans you draw and start putting blocks, putting windows, and so you get the developer or the programmer who will now start using that designs you make to develop the software. You meet a graphic designer who will design the logo, the interface, look and feel, and so on. So we call this implementation stage. Implementation is not just coding alone. Graphic design is part of it. The UI UX is part of it. Then the coding, of course, as you know. And then the source code will be delivered at the end. Because everything, both the graphics, the video, all the multimedia files will be integrated with code. It will interweave them to produce the interface of the software and the functional background of the software. They pack everything together and form another document that you will add to the overall documentation for the software development. So that's what you do in the implementation. And when we talk about the software team, from your side now, from the engineering side now, it's not only you. I've mentioned this thing before, that you are a software engineer does not mean you will do, it's only in Nigeria here where you see only one person. He will do information gathering, analysis, he will still code it, he will do graphic by himself. So in a big company, it's not like that. It's one person per job, one person per job. Even sometimes it's a team per job. You see a team of programmers working on one system. You see a team of graphic designers designing for one program, and so on. So that's your team. Everybody have to partake in the development. Then after development, you now go to the fourth phase, which is testing. Testing here means you have the requirement document, you have the design document, and they have been implemented in the third phase. In the fourth phase, you check this thing that they implemented. Is it how it is in the requirement? Is it what the owner requires? Is it what the owner wants? Yes, okay. Did they use the appropriate technology as I have designed? Because you have designed this document, you have designed these requirements. This thing they produced, did it match the design? That's what testing is. So at that time, you ensure that the software works as expected and meets the specified requirements. Those tests, you can conduct them unit by unit. That's in a small group. You can also test the entire software at once. If you find any error, it is not the end of the road. We mentioned it last week that finding error in a software is normal, is acceptable. It is called bug. If it is not acceptable, it will not have a name. So when you see error as a software engineer in your software, don't panic and don't feel bad. Don't feel ashamed. It's part of it. Where you will not feel bad is if you are unable to correct it. The act of correcting the error is called what? Debugging. It's called debugging. So you now go back and debug those errors. It's during the testing process. That's when you find error and you fix it. If you can't fix it, you are free to consult another engineer, depending on where the error comes in. If it's a programming error and you are not able to find the programming problem, you can find a programmer who you think is superior. The person can come in and assist, or someone you think that have had that experience before, you can come in and assist, and you correct it. He becomes part of your team. That you are allowed to have a team. You are not even supposed to do it alone. After testing it, you now deploy it. So deployment is when you now release the software for use, when you now hand it over to the owner in the way they want it. If they say it's a mobile app, you send it to store. If they say it's a website, you host it. If they say it's a system, offline system, you go and install it on their laptop. That is what deployment is. Then you train them how to use it. After training them, you hand over that document to them. It's their own. Sometimes it's very good to divide the document into two. One is the system document, which specifies everything about that computer, about that software rather, from the analysis to the design, to the code base, to the initial testing bugs and how you debug them. The owners don't need it. They just keep it in case of maintenance. Then the other part of the document is the one they're using often. That's why it's important to separate them, because they don't need this one to be delaying them, trying to search through. The other one is the one we call user guide. You produce a user guide, a sketch that defines how the interface is connected and how to use the software. You produce that user guide and you give them. Even though you have trained them, you still keep that user guide with them so that if they forget what you have taught them, they will go back to the document and read through so that they won't be calling you all the time. To even save you time. So even though you have handed over the document to them, you are still not done. You now enter the last phase. Somebody else. Okay. Who asked the question? Is it Bama Graphics or Abdul Kadai?
I step outside and saw some children in the car. Is there anyone that can children? Okay, so my advice is please bring them in here and come and help us silence this way. So that they don't call your car from right now.
Okay. I've not seen the question, but let me answer it. I hope the person will be listening. Where is it? Richard? We run the world?
Yes.
What technology can be used for app on phone and not mobile application? Okay, there is a language called CSS, Cascading Style Sheets. If you use it, you can make your websites to fit into any mobile device. We say it is responsive. The website will be responsive, meaning that it can fit on any device, including phones of different sizes. Then we have a framework called Bootstrap. If you are using Bootstrap, yes, sir. Bootstrap is naturally designed for this purpose only. In fact, the slogan for Bootstrap is mobile first. Mobile first. If you use Bootstrap, naturally your software, your website will look like mobile app on a phone. All the websites you browse and they fit on your phone, more than 50% of them is done with Bootstrap. So we run the world. I've answered your question. We are going to meet these things when we start doing practical. So you see these technologies firsthand. All right. So in maintenance, you come and take over the work that you have done and watch over it. As they are using it, you are keeping an eye. If they have any problem, they will call you to fix it. Is corrective maintenance. You will also put some things in place to ensure that errors does not occur. That is preventive maintenance. You can also update it. If maybe they have one shop today and the next day Antibola now have two shops because they are now making money. The software is helping them to track their finances, improve their sales performance, and they now have enough money. They have another shop. They still want to use the same software that side, and they call me. As a good structured software, you don't need to start building a new software entirely. You just do a little thing on this software and it's able to accommodate another shop. That is what is called update. think they should be seeing me by now. Where is the man? Check. Am I not back? I'm back. Okay, so this is the. I'm back. Yes. So the waterfall model, you can see the requirements. After the requirements, that's why we say it goes on a straight line. They just want to make it look like engineering drawing. That's why they are making the shape look somehow. It's a straight line. That's what you see is a straight line. That's why we say it's linear. After this, you can draw it like this, you can draw it like this. After requirements, you go to analysis. After analysis, you go to design. After design, you go to implementation. After that, you go to testing. After testing, you deploy. But when you are drawing it, make sure it is having that step level. You do like this, come this way, you put this level. You push out, you do like this, you put this level. You push out, you do like this, you do this level. That's how to draw it for software development. But just understand that it is linear, it's on a straight line. After the waterfall model, we have the agile. So this agile method, let us look at the agile itself before we come back to the group. Agile is a circular form. Waterfall is in linear form. So one sprint or one level of agile, we go from planning, which includes the information gathering, to design, to develop, to test, to deploy, then to review. It will come back again. That's why we are talking about cycle. It will go back again in a cycle and continue until everybody is satisfied. You launch. Now, what makes agile different is the review. You can see there's a review there. After you have deployed, you review it with the people. After teaching them how to use it, sit down with them and watch how they're using it. Is there anything they're finding difficult? Is there a menu that they didn't see on time? Is there a button that they're supposed to click and they are fidgeting? They are not sure where it is, or they are not sure what next to do. You take note of that. Is there a function that the view that you have built that function, but it's not functioning the way they expect? You note it. That is what is review. Sorry. So when you review it, you go back and review the system. So that is one agile. Now let's go back to the group. This group, though it's only 3, but it shows a sign of multiple. It means that if you're using agile method, you're going to hire the software for them. University software university is a large community. Don't think that the university is just people you see in the classroom. It's a community. So if you are building a software for an institution like this, like a university like this, you build for exams and records. That is the one for result checking. You build for hostel management. You build for the Bossa unit, that's accounting. You build for We come back to results. You make sure that all the semester package it and you keep it. You now go to bursa unit. All the payments, those who are owing school fees, other fees, you manage it, you configure it, make sure it's working, you review it, you keep it as a model, as a module rather. If there is another aspect, maybe the report side now, maybe the VC want to be seeing students that are owing, those are paid, those are going to graduate. Also, each module is called sprint. So what Agile does is when you have a large project, Agile will help you break it into modules, small modules. And each module you have to do it, deploy it, test it, review it, continue again until you are done. You move to another phase, going around. Such movement is called iterative. So when you hear iterative model, it means that you go around the circle more than once. You are iterative. You do it, you check, you review, you come back again, you plan it again, you review, you check if that is working, you deploy, you go around it until you are done. So Agile here, they defined it as an iterative and incremental approach where software is developed in small functional segments called sprints. So for you to do Agile, you have to have regular feedback from users. And those their feedbacks, you incorporate it into the development process. That's the essence of the review. That's the feedback. As you are reviewing, you are collecting feedback. How do they see the software? What is hard? What is easy? What do they like? You feed it back. The advantage of Agile method is that it's flexible, it's adaptive, and it's faster in delivery. Why we say it's faster in delivery is that so the result is not even the problem now. The hostel is. So with Agile method, you concentrate on the hostel part, finish it first, and deploy, so that they will continue using it while you are now doing the result part, which will come at the end of the semester. But if you are not using Agile method, you may think that because it's institution, because it's a high institution, that result is the most important, and you'll be doing result. And this thing can take you 6 months. And by then, the headache of the hostel has given them fever, and they are bored with it. But if you do that one that is spending them, they are happy with you. So Agile will help you do that component by component until you build the whole software and put it together. Another advantage of using Agile is that when you are done, if one section of the software is having problem, it will not bring all of the software down. They can decouple that part that is having problem and continue using the other part of the software. Are you understanding what I'm saying? That's why most of the time Agile method is preferred. Even when you are building a small software, you can still use Agile method. Divide those functions in that small software into sprints, into phases, and handle them component-wise. I will come and see what you've done. Some people are still looking at the screen. Is it like you didn't understand what I said? Or you didn't come with your book? This is a practical class, so this theory, we just want you to have an understanding of what we will be doing. This theory will end next week. The upper week will start practical. So you're supposed to be coming to class with your pen and paper. If you have a laptop, it's better, although they provided systems. But if you have a laptop, so that we install those software we'll be learning with on your laptop, so that even if you'll be practicing, because once a week is not enough for the training. So I try to have one. Instead of buying clothes and phones this December, buy a laptop. Yes, no. Because later that laptop will make you money that you can even start selling clothes if you want. Let me see what I'm doing. Okay. I'll talk about this one. The launch come from design. Yes. Okay. Because you cannot say it. Okay. Okay, sorry. Okay, what I see outside is this continuous, yeah, cycle. This is someone asked question. Okay, what is it? Software is the life cycle. Okay, what I want to talk about is that this is supposed to point back to design. So there is one of us here that when he was drawing his diagram, when I got to his seat, what he just drew was a circle. Just drew a circle and wrote agile in the middle. I also have another person that he had drawn this, but what he did, he was drawing this one, so he put this. He was about drawing this when I got to his table. Now, if those two guys stop there, maybe they are writing exam and time stops them from there. Who do you think will score the mark? That's your opinion. You said the one that drew circle. Who else have a view? What do you think about the two guys? Okay, that's the one that did the linear stuff.
Yes.
Okay, the person that would have scored the mark is the person that drew circle. Agile is a cycle. Waterfall is in linear form. So the person that even though I said draw agile, and he was drawing agile, I had drawn these two because he was starting from here. If time stopped them, he would have not gotten the mark. But this guy that drew circle shows that he understands what agile is. Why I'm laying that emphasis is that some people drawing agile, they will draw this and write review. Their review is somewhere like here, and these ones are here. The drawing didn't show a cyclic continuation. Agile have this cyclic continuation. That's why it's a cycle. It goes round. Your drawing must show this roundness. That's why they put this black thing here, just to tell you that we are going round. We are not, this thing didn't stop here. It goes round like this. It keeps going round as many times as possible. It continues going round until this place satisfies this place. That's when it can now go to exit. If the review satisfies the plan, it exits. The cycling is supposed to continue. So that's what makes agile. Anytime you draw agile, watch that that cycling is more important than even what you write inside. Because that's what differentiates agile from other models. So I believe everybody have drawn it. So if you are asked to draw agile, even when you are not an artist, just draw something circular and remember the software development process. The planning, the design, the development, the testing, and the deployment. Even if you didn't remember review and launch, put them in a circle for them. At least you score 70%. Okay. Let me see what people online are saying. Omar Mohammed, you said water. I'm asking you, am I connected or you are controlling it from that side?
I need you to speak for me. So you share your screen.
Yeah, it's sharing. Check if I'm back.
Yes, you're right.
Okay. Should I continue?
But your slides now it's on.
It's on.
It is on now, yes.
Okay. So that is network fluctuation. That's what I think discussing. So we talk about Scrum. When you have all these team, you need to manage them. Remember that last week we said that there are many fields in software engineering that you can follow. As a software engineer, you can decide to major on DevOps. As a software engineer, you can decide to major on quality assurance, which is what we call review in Scrum, in Agile. You say it's review, quality assurance, to make sure that the software meets the quality that is expected of it. In software engineering, you can decide to major as a developer. That's why I was telling us that day that developer, when someone tells you that he's a programmer, you don't have to look down on the person because you're an engineer, because the person is doing an important work for you. So a software engineer can even decide to be a developer and measure there. That's how it is. So there are many aspects you can measure. One of them is a Scrum Master. A Scrum Master is someone that supervises people that are using Agile method. Remember that Agile is used for complex software. When you are building a very big software, then you have a team. The team there includes the database person, the graphic designer, the programmer, all of them. In fact, in some organizations, it's not one person that does the programming. You can have up to 5 or 6 persons programming on one software. You can see 2 or more graphic designers working on the multimedia that is required for that website, especially if it's a content development website or content management software website or software, as the case may be. So you see a lot of persons coming to work on a software. And if you are using Agile method, there is a need for someone to act as a Scrum Master. A Scrum Master supervises the team in a sprint. You remember what we call a sprint? This round of a thing is a sprint. That thing you drew on your paper is one sprint. This is one sprint. So some software can have as many sprints as possible. A Scrum Master is in charge of this sprint. Another Scrum Master in charge of this sprint. Another Scrum Master in charge of this sprint. Scrum, a specific agile framework focused on delivering software in short time box sprints, typically lasting 2 to 4 weeks. Actually, this is just a theory. There is no time limit of what a sprint can last. But when a sprint is given to you, a time frame is given. But definitely it's not 2 to 4 weeks. It can be 2 days, it can be 4 days, it can be 3 months. Why they put 2 to 4 weeks there is for you to know that when you are asked about Scrum, you have to mention specific time. Because you don't just give tasks without mentioning the time that you expect the task to be done. That's what this place is saying. So as a Scrum Master, it's a task that you are giving. Your team is giving, but you are the one supervising the team. You are responsible for that team. You are responsible for that assignment. If at the end of the time, the work is not done, they will hold you responsible. So you have to be with the team. If the work is supposed to last, there is 7 days in a week, and you have 3 sprints to deliver. How long do you think? 2 days. If a sprint is taking 3 days, you know that people are trying to put yourself in trouble because you have to finish it within that time frame. And what will you do? You now have to insist on the team. They must finish this task before they go home today, even if they go by 12. That's why sometimes you see the developers, they don't sleep. They walk around the clock. In fact, when programming started newly, that's a story we had. I didn't say it's true. Some of the developers were going mad because they don't sleep. They always be thinking they must meet up with the time given. So that's how it is. As a Scrum Master, you watch over your team and make sure they deliver as at the time frame that is given to them. So you focus on collaboration. Collaboration means there is a team and everybody in the team is working to meet one goal. That is collaboration. So even if there are 2 or 3 programmers in your team, whatever code they are writing is to achieve that aim of the software requirement that was given. So that is what Scrum Master does. I hope you understand Scrum. So in the software specialization, you can decide to specialize as a Scrum Master. That means you'll be aiming at companies that build what they call enterprise software, very large software. They are the ones that take advantage of Scrum to deliver their software. So they have Scrum Masters who watch over the teams to make sure that each sprint is delivered according to specification and on time. The next software development lifecycle is the one we call the V model. V model is the rainfall model, which is linear, but they organize it in V form, making verification and validation. So verification is they have gathered the information that is needed for the software. They design it, they write the code, they trying to make sure the information they gather is in order. Now, when they are done, at this point, they have done the coding. That means they are done in terms of development. They now start testing it. That's the validation period. They now start testing it. So they test it by unit. They test it when the system have been integrated with other software, other third parties. They now test it as a complete system. After doing that, they will still do what is called acceptance testing. So this acceptance testing is when they now go to the owner of the software and say, use it. Or the users, may not necessarily be the owner, but the users, let them use it. As they are using it, you are watching how they use it. You are getting feedback from them. You're asking them questions. This software, how do you see it? What is hard? What do you not like? What do you like most? You check it from them. Are they encountering any error? You pick those points. Remember, we are talking about development life cycle. Now, look at how the cycling goes. As the testing is going on, if you have found what is wrong or what is not right, you go back to requirement gathering. All the information they are giving you at this acceptance testing goes back to information gathering. You have to go back and ask question again, look at the requirement document. Once you are done, you start building the process again. One thing that V testing does, V model does, is that it helps you go straight to the point. When you encounter any error, you know where to go. If the error is that the whole system failed, you know you have to go to the analysis. If the error is that the owner of the software did not accept it, that means you didn't ask the required questions. Let's say Antibola was expecting that software to be on mobile app, but you didn't ask her where she want to deploy it. Your interest was, what do you want the software to do? She said, okay, I want to use it to track finance flow. I want to use it to track attendance. And that is all the information you gather. You now want to build a website for her. And when you bring it, you say, I can't accept this software. Where will I put it? I don't have a laptop. I want it to be on phone. You have gathered the information they had with. So you have to go back to the information requirements and feed that data inside it and start the whole process again. But if the software fell at system testing, you don't need to go to information gathering. You just go back to system analysis and check how you analyzed the information you gathered. If the software fail when you are integrating other systems into it, you have to go to software design. What we mean by integration, like they want to have, let's take the institution software for instance. They want student results to be developed, result management system. You have written all the codes that will make it work. Then now they want students to receive SMS. They want to receive their result in SMS. They don't want to be pasting it on the wall. The SMS engine, you're not the one that will design it. It's a third-party software. So you're going to get it from the SMS gateway. Who knows any SMS gateway? Mention it. Have you heard of SMS Live? You need to start exploring some of this. SMS is, you're not supposed to start designing it from the beginning. It's just like email service. You're not supposed to design it again. We have email service providers like Gmail, like Yahoo, Rocketmail. So you're not supposed to. So those things are called integration. If the software will be sending mail, if the software will be using SMS, you integrate those things. If the software will do payment, let's say the bursary unit now, they want to integrate e-payment so that students can pay online. You're not supposed to write a code for payment. All you need to do is just to go to Paystack if it's Naira, or PayPal if you want to take dollar, depending on the scope of the institution. So those third parties, they are called integration. If the integration process fails, maybe you integrate the payment, but when students pay, the school is not getting notified about it. You are not supposed to start tracing the error to requirement analysis. You know that you are going to check it from the software design. Are you understanding how V model works? Each error links you to where you should go and check it. If you test the unit and it fails, go to the module design. If you test the integration and it fails, go to software design. So that's how the cycle goes. And that's the advantage of using this V model. It saves time when you want to debug. It saves your time. But one problem with it is that it takes a lot of time to test. The testing, you can see how many days we are spending on testing. You test this one, you test this one, you test this one, you test this one. So there's a lot of testings here. So the last one is the spiral model. Is one of the models in software development lifecycle. So this one goes like spiral. What makes this one unique is the risk analysis. It does what the other software development lifecycle is doing. The information gathering, analysis, design, implementation, testing, deployment, maintenance, all of them are there. But you now added risk analysis. So each of the phase is also circular somehow. Each of the phase goes in circle. As they finish it, they check the risk involved. They do it again. They check the risk involved. They do it again. So they are more interested in risk analysis. If you are doing a software and you are using spiral model, it means that the software you're building, you are considering that there's a lot of risk factors in it. It can include cyber security. Maybe at the end, you do what they call penetration testing on the software to check whether the security is intact. It can also be fear of file loss. They call it disaster. If a file is corrupt, the system is a disaster. For you to see how bad it is. So you have to implement what they call disaster recovery. You have to implement a backup. All these things are not from the requirement. The user did not tell you these things. I mean, the owner did not tell you about these things. It is you who is a system engineer that understands what is required for this type of software you are building. If you are using spiral model, then, or if you discover that there is a lot of risk on this software, then you know you're going to use spiral model. So these development lifecycle models are there, but they have a time when each of them is required. We have said that rainfall model is when you are building a smaller software. Agile is when you are building a large software. Spiral model is used when you think there is a risk, that the software you are building has some element of risk. For example, you are building a software for financial institutions. You know that understanding of this. Not like you are going to leave software engineering and not going to project management, and then you now expect to come and head people in software engineering. No, you must be a software engineer yourself, but that project management aspect will now be an added advantage, so that if you apply to be a Scrum engineer, a Scrum manager, sorry, as in software engineering environment, you apply to be the Scrum master. Another person apply to be a Scrum master, and they look at your CVs, and you say you have understanding of project management. Automatically, you take the job. The same thing with DevOps. Okay, so that's that. Importance of software development lifecycle. Quality assurance. So by following a structured approach, software development lifecycle ensures that the software meets the highest quality standards. We have talked about these things, each of the life cycle you are using have what makes it unique. So imagine someone that is developing maybe a taxi hailing app like Uber app, and he used spiral model. That means he takes care of all the risks involved, including the security of the passenger and the security of the driver also, because both parties can also be in danger. The software will be more of high quality and more appreciated than the one you use Rainfall model to do. That your attention is just on a taxi hailing app. With this app, I can hail a taxi. And you didn't consider the risk, you didn't consider the safety of the persons that are involved. So what I'm saying is that when you use the right software development life cycle, you produce a software that meets high quality standard, because you now take care of some important aspects of the software. The next importance of SDLC is efficiency. So you have a clear roadmap that helps to minimize delay and budget overrun. So this budget is important. I've said it earlier, that you develop a software and you charge the person, even if it's Dangote, if you charge him too much, he may not call you again. In fact, he paid you because he has all the money. Some person that doesn't have the money cannot afford it, so you've lost the job. They won't call you. Now, if you also go and charge too low, you will borrow money and complete the software, because the owner will not want to hear that you come back and say, Auntie Bola beg now, this thing now is more expensive. I was thinking we are going to do it with 50,000. Now it's 100,000. I beg. She won't hear you. I forgot to do my work. I've paid you. You have to go and borrow money and complete it, or you can send you to jail, because you have agreed to do the work. Budget, you have to consider it before you sure you've done the analysis, you've collected all the requirements, and then you do a design to show you understand it, and then you take that design to the owner. Auntie Bola, is this what you want me to do for you? She said yes. Sign. She signed. You now come back, because there's a problem with software development. Somebody will tell you that I want a software that will lift this thing up. You do a software that will lift this thing up. When you now present, you say, I want the one that will lift it up and put it somewhere else. But until that's not what you told me from the beginning. It happens all the time. Anybody that develops software will notice this thing I'm saying. You do a software for somebody, when you present it, they start telling you other things they didn't say before. And they expect it to be with the same budget. The only way out is when you have gathered the requirements and you have done the design, take that design to them. Sir, is this what you want? He say yes, sign. You now hold it. Anytime you now say, I want, if you leave this thing up, you put it here. You say, well, sir, that's not what we say. You say, hey, don't you know you should say, this is what we signed. If you want me to do this second one, you pay me. And because it's signed, it becomes an agreement and is presentable in the court of law if it gets to that level. So that's why software development lifecycle takes care of these things, because each phase, as you follow it religiously, you achieve an efficient software that minimizes delay and budget overrun. Another important is stakeholder communication. So it ensures continuous involvement and feedback from stakeholders, reducing misunderstandings. It reduces misunderstanding so much. There are some people that are cunning. They don't want to tell you exactly what is involved in the software. They just tell you a part so that you charge them less. Then when you now want to deliver, they now tell you more. And they will expect you to do it with the same amount. But if you are in constant communication, they won't even have the face to tell you to do second one. Because you say, but sir, I've been coming to you and this is what we have been working on. Their conscience will not allow them to tell you a different thing. Or if they even dare to do that, you tell them they will pay, they will have to agree. Another advantage is risk management, especially if you are using spiral model. Early identification of risks and problems leading to quicker resolutions. Compliance. Software development lifecycle ensures that all regulations and standards are adhered to throughout the project. So that's why you have to use software development lifecycle when you are building your project. And in your document, you have to draw the life cycle that you are using. You mention it and you draw it. If you go for software presentation, maybe a company wants you to bid for their software and you bidded, you are not the only one that will bid. Another software engineer or another software company will bid. And when you are doing your presentation, that company will hire software engineers too, who will sit at the board and listen to your presentation. After your presentation, if you didn't tell them the model you are going to use, it's a minus for you. If the other people mention the one they will use, they will know that those people know more than you do. But they can as well also ask you, if you didn't mention it, they can ask you, what model do you want to use? And if you didn't plan it at home before coming, you can misfire. You can call the one that doesn't suit that work. And you have started losing the work from there. So we need to plan these things before we do our presentations. So that's the importance of software development lifecycle. Finally, what are the best practices? What are you supposed to do for you to follow software development lifecycle? Number one, clear requirement gathering. We have been repeating this so that you will understand it in your head. It's not like when they ask you about it, you now go and carry book. I want you to, when I will ask you this question, whether in test or in class or in exam, I would like to see you answer it differently. That's from your own understanding. We have talked about requirement gathering severally. We have laid emphasis on it. So much so that you don't even need to, it's not becoming rhetoric. In software development lifecycle, information gathering is key. Because that is where you know what you're doing. Imagine if you just come out, you stop a taxi, where are you going? You've not even planned where you're going. You stop a taxi, and I say, where are you going? And I start saying, the person will just drive off because you don't know where you're going. So you must gather this information. It's the planning stage of the software. So implementing software development lifecycle will help you know that you have to do information gathering. And you do that. Meeting all the stakeholders. The stakeholders include the owner of the software and the users of the software, both those that will input the data and those that will harvest the reports. Another important thing that software development lifecycle will help you do is to maintain documentation. We have also overemphasized the need for documentation. All the maintenance must come from documentation. Even the training guide will come from documentation. Remember that you are not the one that will do all these things. You are not the one that will possibly do the interface. Maybe it's the developer. Or maybe you hire, they even have a group, a set of skills they call UI UX. Who have had that word before? So the way we have programmer, graphic designer, now we have UI UX. That's to show you how large this our field is. So a UI UX is the person in charge of interface, user interface, and they how the users will view it. That's why you even need to ask the education level of the users of your software, so that you know how to do the interface. If you are doing for people that have not used computer before, then you have to use menu. You have to do it in a way that they will see all where they will click. even put some pictures that show that this is what you want here. So all those things will come in the documentation, user guide, user manual, how to. Then the maintenance part of it. So that's the best practice in software development lifecycle. A clear requirement gathering, a documentation, complete documentation. Then regular testing. As you have delivered the software to them, you watch them use it. You test it before you give them. You still watch them use it. Maybe there are certain things you didn't test or things you maneuvered when you are using the software that you didn't know. I gave an example last week. Imagine you did a software for money transfer, and when you are building it, what you have in mind is for somebody to type. If you want to transfer 50,000, you type 50000. You didn't think that somebody may put comma, because you as a developer, you already know that in data types, numeric data type does not allow comma. So as an engineer that you didn't put that comma when you are doing it, and you give it to an ordinary user who is not in the IT field in the first place, and the person put 50,0000, and when you run the code, the system flagged that comma and the thing is not working. So your own testing alone is not enough. Or you imagine when the person is supposed to use it, he didn't even put 50, he put FIFTY space THOUSAND space NAI. So the person is typing it in letters, but what you had in mind was numeric value on that test field. How will your code handle it? So, but when you tested it, it was in order. But when you deliver it for them to use it, it wasn't in order again. Not as if your code is wrong, but you didn't take care of those stuff. So software development lifecycle will help you test and review and test again and follow that cycle until the work is acceptable generally. Of course, you can use version control. That's the GitHub. You use Git to manage the phases of your software, and then iterate quickly using agile practices. So agile will allow you to build your code module by module, component by component, and then you couple them so that you have a software that is robust and that can continue to work even when a part is bad or down. The other parts will continue to work. So that is what we have for today. Software development lifecycle. So if you have a question, you want to ask for clarity or suggestion or even objection, you can state that. Yes?
I want to ask, in the gathering and information gathering process
Yes.
of the SPLC, is there any kind of template of question and questionnaire you have to have handy and for engineering and output that you can use as a checklist that you know that can fit into any project? You just know that, okay, these are the 20 questions, so to say, and you can just go through to help you fast track rather than every time you have to generate the questions afterwards. So there's something like that.
Okay, thank you very much. And because in software, why we say this is custom software, customized, you are sewing it. I'm using sewing now, like a tailor. You are sewing it according to the size of the person's body. That is, you are building it based on what this person wants. It's not a commercial software. At each time, you must generate the question you will ask. But there are some that are basic, no matter what the software. Something like which platform are you deploying? That is it going to be mobile or web or this? Number two, what budget are you expecting? Then number three, who are the users? Are you the one using it or is it your staff? Who will view the report? Is it you? You find out who the users are. These ones are basic. Then other questions will now be as a result of what the software they want to build. But we thank God for ChatGPT. Who knows ChatGPT? So if you ask me to build a software for you that will sew clothes, I will just open my chat GPT and ask him, generate software requirement questions for, and I write what the software is about. ChatGPT will now give you all of them. But remember that ChatGPT will also tell you that he's just an AI. So don't swallow what he said. So check it. But sometimes it will give you a bogus list that Antibola will not have patience to listen to all those questions. So you pick those ones that are important and even add the one that the ChatGPT could not put. Are you following? But ChatGPT will make it easier. But experience will also make it like at where I am now, I don't use ChatGPT again. If I want to do something for you, when you tell me what it is, I already know the questions I will ask you. So as you mature in the field, you don't need ChatGPT again. But as a beginner, maybe you use it to guide yourself. Okay, so that's a good question. Any other question or observation?
I have a question. You talked about budgeting.
Yeah, budgeting.
So my question is that when you are building these softwares that are like enterprise software that are
Yes.
very, very big. In terms of budgeting, you know those softwares sometimes they might be boosted.
Mhm.
So the budgeting for those softwares and like is there a template that shows us like we are new on how to actually host these softwares and is the financing going to be covered in the budget that we are giving to the customer at the first place or you have to go and tell after building you have to tell the customer to go and host it.
No, how can you tell you that is you that is in IT? Do you know how to host? You're not telling someone outside to go and host it. No, you can't tell them to go and host it. Except it's an organization, it's a company. If you want to just be 100% sure, you can ask them, do you have in-house person that will host for you? Or they can say, build and give us. We already have our domain name we want to host. But if it's a client outside there, you can't tell them to go and host. You build it in the build. To know how to host is also not hard. You look at host. We are going to look at hosts practically as we continue the class. But you can as well go online, go to Google and say hosts. It will give you a list of hosts. And when it gives you a list of hosts, okay, this one is looking at it like I want him to define what host is. So I can say list of website hosts. So I've already seen 10 best hosts. If this is the cost that I want, I can also search it as cost of website hosting, and I will see the amount from the system. Anything you want is online already, so you add it to the bill. Then how you know how much you will charge them depends on how many days this work will take, because we usually charge per hour, but you can charge per day if you want to. So you can think that if this work is going to take us 3 months, how much are we supposed to charge for a day? Maybe 10,000 a day. You multiply it by how many days you make a month. Charge multiply it by 90. That's about 900,000. If your bill is 10,000, and that is for you. So what of your team? How many people do you think will work on this project? And how much do you think each of them will charge within that 3 months? You put it, and that will give you an idea of what you will put. Software is not cheap. Software is not cheap. Some people use, like my friend Mara was telling me about the software they want to build, and they are planning 50 million. 50 million for the project, his company. So software is not cheap. So you can see that by the time you check it, okay, only you is taking 900,000, and maybe you guys will be 4 in building the software. If they are taking the same amount like you, 900,000 times 4, that's about 3.6 million. Then you now consider the hosting. The hosting can be 200,000 or 150,000, depending on the way you want to host it. So by the time you put these things together, you see it's about 4 million. A software that will take you like 3 months. If the software will take like 2 weeks, but there are software that are also as small as take only 2 weeks. So you consider it, if you are taking 10,000 a day, 4 of you is 40,000, and it's taking 2 weeks. 40 times 14. So that's about what you charge, 280. So that's what determines how much you will charge. Another thing that can help as a beginner, you consult somebody that you think that knows. That's okay, how much? Because if you undercharge, the person will not pay you again. No. You will go and borrow money and complete it. We've seen cases where people borrow money to complete software, use their own money they have already to complete it because they undercharged. So that's how it is. So that's a good question too. I hope you got the answer you see. Did that answer the question you asked?
Yes, sir. Yes, sir.
Okay. Let me see if people online have questions.
When you were listing models, you said 5, but you gave us 4. Was it an oversight?
Yeah, maybe it is. I think it should be between 4 and 5. Spiral model D. So D is 4.
4.
Then this is 4. But software development life cycle is 5. I don't know the one that is missing. Maybe find it out. You can find it out. It's 5, but what is here is 4. You said? Online, okay. So when you're talking about agile, you said that someone have to collect feedback from users steady when working with the agile model. Does other models need feedback from users? No, other models do not make room for that. What they make room for is the user requirement. When you're gathering it, that's when you ask questions. And again, when you are testing, you test it within you and your organization. Any other fault that's found out will now come under maintenance. So that's what is different with agile. That's why agile goes round and round. When agile gets a feedback, it go back again to develop the software. But others doesn't do that going back. They just go ahead and deliver it and wait for you at the maintenance. Any other fault, they come under maintenance. So that's why agile seems to be more acceptable. And that's why they created that office called Scrum, specifically for agile. When the job is remote, most of the times I'm answering this question. He said, please, if it's a remote project, how can we take signatures and make documentations? In fact, almost all the software jobs are remote. Like my company in Port Harcourt, we have been doing job for people in Europe, people in America, people in Abuja, people in Lagos, people in Owerri, and also people in Port Harcourt, even without going to their office. Someone will just tell someone, I want to do software. Sir, need code space now. If you have their number, yes, the person will call. Hello, who is this? Say, I'm Alaji so and so. Is that code space? Say yes, okay. I want to build a software for this, that. That's okay. I will send you something. I will just send the requirements, the questions I want to ask. I will send it to the person in PDF. I says, I supply this information and send to our mail. They have not seen me, I have not seen them. They will supply all those information and send it to our mail. We look at it, do a design, analyze it, and say, okay, this is how much it will cost you. This is our account number. And this is the design for it. Indicate that this is what you want by attaching your signature. They will attach. If they think that the software has some kind of intellectual property, they will send us a document called non-disclosure agreement through the email. We read it through. Then the last part, which is the signature part, we'll sign it, scan it, and send it back to them to show that we have agreed. The next thing is alert on our account. We start. They don't need to know where our office is, even if we are in the same Port Harcourt. So, answering your question, almost more than 50% of software job is remote. You don't have to go to your client. The client don't have to come to you. It's by recommendation. So they can give you signature by scanning it and sending. Or if they have signed it already, they can snap it and attach it through a MS Word as a picture and then send it to you. Okay, someone was saying something. Richard Augustus. Let me see what you're saying. He said that they built a software for a company he worked for. Our production process is unique, and the app had to be tailored to our need for it to work. We have series of back and forth because of changes needed to be made. Please, how did you manage this problem? That's why documentation is important now. If you have done documentation and information gathering, you don't need to go back and forth. And again, like I've said it before, some did it by not knowing. Some people are cunning and do it intentionally. They will tell you just half part of the story so that you charge them less. When you now come back, they now tell you all of it, thinking that you will use the same amount to do it. That causes the back and forth. But sometimes it's also the fault of the developer, the engineer, who did not collect all the information you need. We have said here that there is functional requirement and non-functional requirement. Who can tell us the difference between the two? What is functional requirement? What is functional requirement? What's the difference? I'm asking the class. We have discussed it before. Who can tell us? Just raise your hand and tell us. Yes. That's a phase one of the understanding. Functional requirement is the one that the owner of the software tells you that they want. Because when you develop the software, that is their yardstick to measure it. I told you that I want software that will do this, do this, do this. Even if you do all the things in the world and that software is not doing that thing the person said, you've not done the software for that person. That's why you call it functional requirement. Now, non-functional requirements are those ones they didn't tell you, but it's important. So that's one way to define functional requirement. But another way to define it is those things that the person did not say, but you can dig it out by your information gathering. We've given an example severally. Like, let me remind us the example again. Antibola said, do a software for me to manage my office. That's what she said, and that is the functional requirement. When you are gathering information, you now ask her, where do I deploy this software? Is it here? Is it on phone or on system? It is also a non-functional requirement because she did not say that. You are the one that find it out. So sometimes we don't just swallow what the client say. We go for information gathering to ask those questions that are key. And when we are done, we document it and show them, is this what you want me to do? And they say yes, you say sign. Once they sign it, Richard, are you listening? Once they sign it, there is no going back. Back and forth will not happen again because you now have a working document. If they want extra work, they have to make another payment and another agreement for that extra work. In that way, you will not go back and forth. Your question says, please, sir, how did you manage this problem? And I've given you the answer. Do proper information gathering, document it, and let the owner of the software, let the client sign it, and then you go and continue your work. When he needs extra things, he pay extra for them so that you won't be going back and forth. Ahmed Nafizi. What? Nazifi. Is that not how to call it? Okay. He said waterfall, agile, V, and spiral model. Are they types of system development life cycle? Yes, they are the software development life cycle models. Okay, there's a link shared. I think this link is for them to do attendance. We've done attendance here now. Yes, Mr. Olara, you are right. That's what functional and non-functional is.